Astronomers peering deeply into the cosmos think they have found something remarkable: the light from the first objects to form after the universe was born.
This is the hidden universe of the Spitzer Space Telescope, exploring the mysteries of infrared astronomy with your host, Dr. Robert Hurt.
So do you think you can get something from almost nothing? Dr. Sasha Kishlinsky of NASA's Goddard Space Flight Center thinks that you can. He and his team have stared deeply into the backgrounds of images from the Spitzer Space Telescope, in between all the obvious stars and galaxies. And what they've found may well be the very first objects to form in the universe. From what we know about the Big Bang, everything in the universe burst into being in a tremendous explosion 13.7 billion years ago. This includes not only matter and energy, but space and time as well. The initial afterglow soon faded, and the expanding universe was filled with cooling gas clouds of hydrogen and helium. During these dark ages, gravity slowly pulled the gas into filaments and clumps. After about 400 million years, the densest regions lit up with the very first generation of stars.
If the first populations of stars were very massive, unlike anything we see today, and it is thought on theoretical grounds that this is what they should have been, they should have produced enough light with enough structure that would be measurable in measurements such as what we have done here.
Such stars would have been brilliant and huge, maybe as much as 1,000 times the mass of our Sun. Their nuclear furnaces forged the very first elements in the universe. Supernova explosions recycled these new materials back into space, giving later generations of stars the building blocks for making planets and even people. To look for this first population of stars, Dr. Kishlinsky and his team used a series of very deep exposures from the Spitzer Space Telescope, which stared at these small patches of sky for many long hours.
So we took deep images and we eliminated the foreground galaxies, and we could see this glow produced by the objects that cannot be observed in normal telescopes. So these are the very first and very early populations in the universe that we cannot see currently by any other means.
Because this light has traveled for so long and so far across our expanding universe, it's not possible to observe it with visible light telescopes. The original ultraviolet and visible light photons have been redshifted to the infrared part of the spectrum that Spitzer was designed to study. These distant objects are so tiny and faint they can't be seen individually, so astronomers actually blur the images. This brings out the combined light patterns that provide clues about these mysterious objects. It's like looking at a fuzzy picture of fireworks and figuring out what the sparks are like.
So we know that these sparks had to be individually faint. Faint meaning they had to be at very large distances from us. And when we reasonably assign distances to them, we place them well within the first billion years of the universe's evolution, which is when the first objects had to form.
Kishlinsky's team initially reported this result after studying a single patch of sky. But if you're going to make a claim that applies to the whole universe, you need to make sure the result is the same everywhere. Now they've studied 5 different areas, and the results all match. Interestingly, this was a very efficient use of Spitzer's time. Kishlinsky's team scientifically recycled images that were already available from other research projects.
So we essentially used what others did not use to get our signal was what others were not interested in.
It's difficult to determine exactly what generated this diffuse infrared background light. Astronomers believe it could be coming from the first generation of massive stars, or perhaps from superheated gas that is falling into ancient black holes. Either way, they hint at the beginnings of galaxy formation that eventually led to the Milky Way. But for more answers, we may have to wait for upcoming missions, like the James Webb Space Telescope, which is designed to study this early era in greater detail. For the Spitzer Science Center, I'm Dr. Robert Hurt.
The Hidden Universe is produced by the Spitzer Science Center at the California Institute of Technology in Pasadena. The Spitzer Space Telescope mission is managed by NASA's Jet Propulsion Laboratory.